Welcome, students. Today we're going to look at dividing polynomials. We're going to look at two different methods that we can use. We'll look at long division and we'll look at synthetic division, and we'll see how synthetic division can be very useful. So we'll start with long division, and we're going to do one example here. So let's evaluate 6x squared minus 26x plus 12 divided by x minus 4. Now, when we are dividing polynomials, we actually set it up like a long division problem. The first polynomial goes on the inside of the division symbol. So 6x squared minus 26x plus 12. And then the second polynomial goes on the outside on the left. Now, there are a lot of similarities between long division of polynomials and long division of numbers, but of course polynomials are more complicated, so it's a little bit more involved. If these were just numbers, we would ask ourselves, how many times this goes into this? Of course, it's much more complicated here. So what we want to do is we want to look at the leading terms. We want to look at x and we want to look at 6x squared. And we need to ask ourselves, how many times does x go into 6x squared? Or equivalently, what can we multiply x by to get 6x squared? And if we multiply x by 6x, that gives us 6x squared. So this is a little bit different from regular long division. But once we have what goes up here, just like regular long division, we're going to multiply this times this and put the result down here. So 6x times x is 6x squared. And then 6x times negative 4 is negative 24x. Now remember, in long division, after we do the multiplication, we need to subtract the second row from the first. Now when we're subtracting a whole polynomial, remember that the subtraction has to get distributed to each of the terms. So the easiest way to do this is to change the signs here. So 6x squared will become negative 6x squared, and negative 24x will become positive 24x, and then we can just combine like terms. When we do this, 6x squared minus 6x squared is nothing. Those are going to cancel out. And then in the next column, negative 26x plus 24x is negative 2x. Then we can bring down the next term and do it again. How many times does x go into negative 2x? Or what do we multiply x by to get negative 2x? Well, the answer is negative 2. So we put that in the next space in our answer, and then we multiply again. Negative 2 times x is negative 2x. Negative 2 times negative 4 is going to be positive 8. However, remember that we are taking this first row minus the second, and when we subtract a whole polynomial, we distribute that subtraction, and so what we need to do is change the signs. So that becomes a positive 2x, and the positive 8 becomes a negative 8, and then we can combine like terms. Negative 2x plus 2x cancels, and we should always have cancellation here for the first term. And then we have 12 minus 8, which gives us 4. Now, anytime the thing that we end up with down here has a lesser degree than this polynomial, we can't continue anymore because you can't multiply x by anything nice to get 4. If it was 4x, we could continue, but we can't continue here, so this is the remainder, and so the answer that we end up with is going to be 6x minus 2, and then plus that remainder over the divisor. the number that, or the polynomial that we were dividing by. And so this is what we get when we perform that long division. It's just like a regular division problem if we have numbers. If we were to take 59 and divide it by 4, 4 goes into 5 one time, and then 1 times 4 gives us 4, and 5 minus 4 is 1. So once we know what goes up top, we multiply, put the result here, and subtract, just like we did here. We multiplied, we put the result here, and we subtracted by distributing that negative. Then we bring down the next thing, in this case 9, and we do it again. 4 goes into 19 4 times. 4 times 4 is 16. When we subtract, we end up with a remainder of 3. And since 4 can't go into 3 because 3 is too small, 3 is the remainder, and this ends up being 3/4. So 14 and 3/4. It's very similar to what we do with numbers. It's just that polynomials are more complicated than numbers, so of course there's going to be more going on. It's very important that you look at some of the other example problems, because this one is a fairly basic problem, and there are other situations that we can run into. For example, I want you to consider the division problem 8x to the 4th plus 6x squared minus 3x plus 1 divided by 2x squared minus x plus 2. If we go to put the first polynomial inside the division symbol, 8x to the 4th, we notice that there's no x cubed term. We jump from a 4th degree term all the way down to a 2nd degree term. In this situation, we actually need to put in a placeholder, 0x cubed. And if we don't do that, then things won't line up when we try and cancel things and combine like terms. And this ends up causing a problem. So there are other scenarios that we're going to run into later that we didn't get to cover in this first problem. So it's very important to look at the other examples to make sure that you're confident with the different situations you could end up in.